Yes. Let's go ahead and strap some glorified fireworks onto a flammable biplane, and then use it to attack things that are filled with even more flammable hydrogen. Yep, aviation in the First World War was indeed bonkers. Hello and welcome back. I'm Christopher Rex Emerson. I do like to talk about planes a lot, and yes, the channel does have some updated artwork. I hope you like it because it's staying. It took me far too long to make. This is part of an ongoing series of changes that I've been gradually making in response to the scary world that is YouTube, owing to the ongoing flood of AI slop that's coming onto the platform, and I'm trying to prove to as many people as humanly possible that I am indeed human. Now, for those of you that will miss it, the old channel logo will be making a comeback on various items and things that I'm hoping to have set up in a sort of small merch store that I'm wanting to launch in the near future, just as another way of supporting the channel and all of the work that goes on behind the scenes. Now, speaking of supporting the channel, this is part of a new video series where Patreon supporters and YouTube members get to pick a video topic. Now, full disclosure here, I did get the idea for this from my good mate Chris, who runs another YouTube channel called The History of Everything. He's had a lot of fun making these shorter, supporter-chosen videos, and I've been looking for an excuse to make some shorter videos as well, not only because I want to change of pace, but it's also going to help me build up a backlog of video content for the channel, which will then allow me to continue to focus more on the longer videos without stressing about nothing being uploaded for the past several weeks. Also, although people have been enjoying the longer content, I have seen a lot of comments from people requesting some shorter videos as well, as they don't always have the time dedicated for a 1, 2, or 3 hour marathon. So, hopefully this is a solution that makes everyone happy. Okay, so let's get back on topic and actually talk about why we were strapping rockets onto rickety old biplanes at the start of the First World War. If you were a British or a French person living in a major population centre in 1915, it would have been all the rage to be utterly terrified of airships. The looming threat of German Zeppelin raids led to many inventive proposals for solutions to the question of aerial defence, as, at the time, these cities could be bombed and not really have a method of responding to it. One of the more interesting proposals came from a French engineer by the name of Henri Guerre. He proposed the use of defensive rocket batteries that would be installed around the city of Paris. These were essentially based on the signal rockets that were then being used by the Army and the Navy, often for nighttime operations. His rocket system was tested, but there was no official follow-up. The rockets had a limited range of only a few thousand feet, and they proved to be woefully inaccurate. The main problem with the rocket batteries, though, was that they were fixed in place. They couldn't be moved. Airships tended to move, and this presented something of a challenge. If these batteries were to be installed, you would need to install a lot of them to effectively cover and defend the entirety of the city of metropolitan Paris. A partial solution was, of course, to use mobile launch platforms, but the ground-based batteries would not solve the problem of range and accuracy. They were simply too far away from their targets. But then, someone had the crystallizing idea of sticking some of these rockets onto an aircraft and using the aircraft to hunt down and attack the Zeppelin at a much closer range. And that person was a French lieutenant by the name of Yves Le Prieur. Prieur was an inventive man, and today he's better known for his work that helped pioneer the development of scuba diving equipment. But he was also keenly interested in aviation, and he would become the first man to make a heavier-than-air flight in Japan in 1909, although it was admittedly with a glider. His proposals for a rocket-equipped aircraft were initially rejected, however. The French Air Force felt that there was just too much risk involved in attaching a bunch of these onto a flying machine that was made out of mostly doped fabric and wood. There was an understandably high risk of fire. But, following Zeppelin raids on Paris in early 1916, the mood quickly changed, and he was given approval to develop a special torpedo aircraft. The torpedo in this case being an aerial rocket. Le Prieur approached this problem carefully. He didn't just stick some militarized fireworks onto a biplane and cry out voila. He designed a system that hoped to maximize accuracy, effectiveness, and also maintain safety for the pilots involved. The system he developed eventually used 2 different designs of rockets, although 4 were planned. The application of these rockets would of course depend on the target. If the target was an airship or a Zeppelin, They would use the Z rocket. If the target was an observation balloon, and most of the Central Powers operated something known as a Draken balloon, they would use the D rocket. The Z rocket was the more complex design of the two, although complex is probably a bit of an overstatement. Most of the rocket was made up of the main propellant section, which included 200 grams of Ruggieri propellant. After that, you had a smaller section which contained an aluminium-based pyrotechnic composition. And then at the front, you had a streamlined nose, and attached to that nose was actually a sharp triangular blade. This was used to help penetrate the envelope of the airship and its hydrogen bags. Once all of the propellant had been used up, the aluminium-based pyrotechnic composition would then get ignited from the residual heat. This was designed to provide a second ignition source when attacking Zeppelins, as it was designed to melt onto the aluminium framing of the airship and hopefully through heat set things on fire and then trigger the main conflagration with the hydrogen bags. The D rockets were similar in shape, except the pyrotechnic composition was removed. This was because the balloons were balloons and had no large metal internal parts and were in general far less rugged than airships, and simply using a lot of propellant to ignite them by firing the rocket into the balloon would be more than enough to destroy it by fire. The rockets themselves were installed in a fairly rudimentary installation. They were essentially mounted in thin tubes that were attached to the outer struts of a biplane, like a Farman or a Newport. The tubes were about 1.5 meters long, and they were angled upwards at about 7.5 degrees. Obviously, firing off these rockets from a plane, particularly from these struts, does present something of a fire risk, and because of this, the struts that they were mounted on were covered in thin plates of steel, which had asbestos sandwiched between them as an insulator, and the leading edge of the lower outer wings, and the trailing edge also, were coated with thin sheets of aluminium as well to hopefully prevent the doped fabric of the wing from catching fire. This took a bit of testing to get right, static ground testing obviously, not in flight, but eventually they got this down to an art form and there were very few cases of rockets igniting the planes they were being launched from. Now, obviously back then, rockets weren't exactly the most accurate of armaments, and because of this, Le Prieur designed a special guide sight for fighter pilots to use when attacking airships and static observation balloons. The aiming sight for attacking balloons was very rudimentary, but the one used for attacking Zeppelins was a lot more advanced. It used a series of rings that would be used to judge the distance between the fighter aircraft and the airships. If the diameter of the Zeppelin matched the circumference of the largest ring, they were at a distance of around 200 meters, the next ring down 340 meters, the next ring down 470, and then the smallest ring would indicate a distance of about 600 meters. Obviously, this did vary depending on the design of the Zeppelin, but it was a good rough overall guide. The standard method for attacking a Zeppelin was as follows. The fighter pilot would initially fly parallel to the Zeppelin at a distance of around 800 meters, and with an altitude advantage of about 50 meters. Once he'd caught up and had become parallel with the nose of the Zeppelin, the pilot would gradually close the distance. At about 400 to 600 meters distance away, he would then turn in sharply at a 90-degree angle and start the rocket attack. Timing of the attack was of course incredibly important, and because of this, these rockets used an electric ignition system. It was provided by a 2-volt battery that was installed in the fuselage, and it allowed the pilot to control how many salvos of rockets he fired, 2, 4, 6, or 8. Attacking the static observation balloons, on the other hand, was a far more straightforward approach, and I mean that literally. Pilots would fly above the balloons, at an altitude advantage of around 400 to 500 meters, and they would perform a sharp dive at 45 degrees and begin their attack at a range of 300 meters. It was important, though, for the pilots to come in the same direction of the wind. This not only allowed them to line up cleanly with the target, as the Draken balloons were orientated using the wind, but having a following wind meant that much less of the smoke and the sparks would be flying towards the pilot's face as he is launching these rockets onto the balloon. Now, this rocket system was initially tested using some hastily converted aircraft in the spring of 1916. and the results were so promising that they were permitted for use in live testing before production orders had even been placed. And by live testing, I mean testing on the Germans. On May the 22nd, over the Battle of Verdun, an air-to-air missile, and it does classify as a missile, would be used for the first time. 8 Nieuports took off from Verdun to attack various German observation balloons, and within the span of 1 minute from engagement, 6 German Drachen balloons were going down in flames. This was an incredibly successful first raid using a very experimental weapon, and this success led to a surge of interest in the new rocket weapon system. Contracts were soon signed for the production of thousands of Le Prieur's rockets, and by the end of the war, over 40,000 would be produced. While the French would be the primary users, the technology was also adopted by the United Kingdom, Belgium, and Italy. Notable aces who would use rockets in these aircraft included Charles Nungesser, Willy Coppens, and Giovanni Ancelotti, the latter of whom once famously flew his Nieuport 11 fighter directly through the flaming debris of a balloon that he had just attacked. So he definitely gets points for flamboyance. Supposedly, Le Prieur rockets were also responsible for destroying 2 aircraft during the war as well, but sources either conflict or they provide nebulous information at best. It is likely that a fighter aircraft from No. 60 Squadron of the Royal Flying Corps, flown by Lieutenant Walters, did blow a German LVG out of the sky, but there are no other witnesses to substantiate the lieutenant's claims. It is likely that he did it, but there is no proof. In all, over 50 balloons, and perhaps an aircraft or 2, were eventually brought down by Le Prieur's rockets. But despite their psychological impact, and it was quite shocking at the beginning, and early successes against balloons, the Le Prieur rockets would never successfully bring down a Zeppelin. This was not helped by the fact that so many of them proved to be defective, and this wasn't due to poor quality design, but poor quality manufacturing. In the factories, the quality control was practically non-existent. Apparently, a junior officer who was responsible for inspections of the completed product once accepted an entire delivery batch after merely asking the workshop manager if there was anything new to report. He didn't actually check them at all. There was not a single box opened up, the rockets expected, the things you would want to have happen. And one of the things that should have definitely been reported earlier was the massive amount of mold and degrading cardboard that was being found in a lot of the delivered shipments. Unfortunately, most of the rockets were being stored in a warehouse that was originally used to grow mushrooms, and because of that, it was a building that had been designed to be a damp building in the first case. You do not store cardboard rockets filled with black powder in a damp building and expect them to be fine. That is madness. But aside from literally rotting, the rockets were often just poorly made and poorly transported, and because of that their reliability was so bad that the French Air Force eventually decided that the engagement range would have to be reduced to a hazardous 150 meters distance for them to be considered effective as weapons. By the autumn of 1917, the operational use of these rockets was rapidly declining. This was partly because of the aforementioned reliability problems, but mostly because of the development of incendiary ammunition, which rendered them obsolete overnight. Incendiary bullets were more effective, they were less risky to operate, and they were much cheaper to make. Now, some aircraft did continue to use the rockets all the way into the mid-spring of 1918, but that was only because the incendiary bullets were so popular that there was a supply shortage, and the poor pilots had to fall back on the incendiary rockets that were now growing mushrooms of their own. The final rocket kill was on the 21st of June 1918, and this was achieved by an Italian pilot by the name of Flavio Baracchini, who shot down an Austrian-flown Drachen balloon. But by that point, the rockets really were an outdated technology, and one that most people were glad to see the back of. By the end of the war, they had a horrible reputation, and no one considered them to be an effective weapon in aerial combat. The use of these aerial rockets was decades ahead of its time, which is why their success was so limited. With the development of better materials, and more importantly, effective guidance systems, the airborne rocket would eventually become a potent addition to the aircraft's arsenal, and then it would quickly become its primary weapon. But that is a story for another day. As always, thank you all so much for watching. And a big thank you, of course, to the Patreon supporters and YouTube members who help keep this channel going. Okay, when this goes live, I should have updated both Patreon and YouTube with the links to the video request forms, and that will also provide supporters with more information on how all of this now works. So please go nuts, request any topic you like as long as it's vaguely aeronautical, and I will do my best. A big thank you, of course, to our Wing Commander tier supporters, our highest tier members, and a warm welcome to Michael Marshall, who is the newest member of this special group. Now, on the topic of Wing Commanders, you will have the option to either pick a topic for a short video, or you will have it made into a long video that is up to 40 minutes in length, but with the caveat that I cannot guarantee a timeline for the latter, so that is food for thought. You can either vote for a shorter video or a longer one, your pick. But that is all for today. I hope you enjoy the new channel artwork, and I hope people enjoy picking various topics for me to talk about. Thank you all so much for your continued support, and I will catch you all next time. Goodbye.